Well, good morning and good evening and good afternoon, wherever you are. Hello and welcome to the December 2021 Masterclass for App Delivery and Security. It was formerly the Networking Masterclass. And this is the series where we cover all the things about delivering and securing applications with Citrix products, how to do it, and the benefits it brings. My name's Jason Poole, and I'll be your host today as we take a glimpse into the fascinating world of application modernization and cloud native applications. Well, a first step. Anyway, you'll see what I mean in a moment. As I said, I'm Jason Poole, your host and asker of interesting questions and chief clarifier. I'm joined by my two esteemed guests here today, Kevin Poe, who's a lead system engineer with a focus on Citrix ADC and application delivery based in the US, and Komal Bhardwaj, one of our app delivery and security product managers based right in the thick of the action in our Bangalore office. And that's the place where it all happens, where new features are born and new platforms are instigated. Okay, so what are we going to talk about? Those are the people. So it's a small audience today, a small presenter audience today. And what are we going to cover? So I mentioned we're taking a short foray into cloud native and application modernization. And we often get asked by our customers, many of them are heading down that cloud native route to modernize their application. And it brings some serious benefits around business agility and competitive advantage, as it really does enable organizations to respond to the needs of their customers more quickly and bring new apps and services to markets faster. And with the developers beavering away coding and for the modern era, the networking team is frequently left sort of holding the can when it comes to ensuring that these new apps are delivered and secured effectively. And many networking admins come to us and they ask us, well, how can Citrix help them do this? This is important for the business. How can I make sure that these new services we're introducing, we get the most out of them? And today, Kevin's going to spend some time to introduce the subject of cloud native applications and address the topic of containers and Kubernetes and give a grounding in that topic for everyone here. And after that, Komal's going to spend about 15 minutes showcasing the new application delivery and security community platform, which is something I think that should interest everyone on this webinar, as it's a really useful portal that's crammed full of useful tips and tricks and articles that help you with your Citrix ADC deployment. Okay, so let's move on. I guess we've got some timings on there. I guess will be a little over an hour with questions and stuff like that, but keep those questions flowing and we'll get to them as soon as we begin. Okay, so Kevin, thanks for taking the time to be with us today. I think this introductory topic is probably long overdue for the masterclass. It's a fascinating way to develop apps. So I'll turn it over to you and listen intently. And let me just make you the presenter. There we go.
Thank you. Appreciate it.
There we are.
Thank you. Thank you. And just to show that it is live, it's going to take me a second to get this up on the screen. So just one moment, please.
Okay, no worries. So while we're there, okay, so we've got Kamis is in Egypt. So hello from Egypt and hello back to you, Kamis. Okay. Okay, Kevin, it's all yours.
Perfect. Perfect. You guys can see my screen, right?
Yes, we can.
Wonderful. Thank you. So welcome. Welcome everyone to today's masterclass. Like Jason said, my name is Kevin Poe. I have been with Citrix as an application and delivery security SC for about 7 years, and I'm very, very happy today to be presenting that international rather. And this gives me an opportunity to educate the world on a topic that I am personally very, very passionate about. That being the understanding of the relationship between NetScaler or ADC and Kubernetes, right? Cloud native computing. Every article that I personally have found online has attempted to explain what I'm about to teach you, assuming that you have a lot of prior knowledge, right? Whether it's to containers, Kubernetes, or even advanced Linux concepts. This is problematic for people like me who have very little knowledge and leaves me behind right from the get-go. Even some of my colleagues here at Citrix have tried explaining this to me before, and they could never really communicate to me the foundational knowledge that I needed to bridge the gap and connect all these pieces together. So I'm hoping to break down that wall for you guys, do something that they could not do for me. So should you only understand containerized traffic flow at a very high level, it is my goal today to give you this light bulb moment in your understanding of Kubernetes. So this is very likely 101 knowledge for a lot of you. and likely contains some gross simplifications, right? However, I do believe that these gross simplifications that I'm making today are necessary so that newbies, right, like us, can bridge that knowledge gap. You may not pass a Kubernetes certification right after my class, but you will most certainly be able to talk about it intelligently when it starts popping up in your line of work. So with that being said, let's get going here. So first things first, right? Let's talk about containers, right? What are containers? And I think a good place to start is perhaps to ask a better question, which would be, what are VMs, right? As we all know, VMs are operating systems that are no longer tied down to a specific piece of hardware, right? Thanks to the hypervisor. As long as you place a VM on a compatible hypervisor and a compute architecture, we can run an image of that OS, right? This makes the OS much more portable, right? This was mind-blowing back in the late 2000s and has its advantages that we are now all very familiar with today, right? Applications could then be installed on the OS, and because the VM itself was portable, the application was also portable. However, the application was very dependent on the OS, right? Certain libraries or DLLs, right, must be present, or even requiring a very particular version, right, of these libraries. So this means even though the OS is portable, the application was not, right? Containers fix this problem by adding a layer of abstraction, just like the hypervisor did for the operating system. So you can see on the right-hand side of my diagram, that is the Docker engine, right? That's that green section there, right in the middle. So this can be seen as the hypervisor, right, quote unquote, for applications by creating an image of an application where we bundle the app itself and its required libraries, right? This makes the app portable. So meaning that the application will run as long as we deploy this image on a compatible operating system and CPU architecture. So why this additional layer of complexity, right? I asked myself this question many times. Why not just continue to deploy VMs with applications pre-installed and configured? So I have discovered that there are many answers, but primarily so that we can upgrade or downgrade applications very easily, right, without disturbing the underlying OS or or vice versa. So basically it means that we can just delete the Docker container or deploy a new container with this required new revision, right? We can also run multiple applications on the same OS without worrying about library conflicts. And from a resource perspective, if we run multiple applications in one OS, there are resource savings because we no longer have to run multiple copies of the same OS needlessly. So the bottom line is that it makes your application much more agile in terms of maintenance and development. So now that we have an understanding of what a container is, what is Kubernetes? Right, Kubernetes is an open source container orchestration platform that attempts to automate many of the manual processes, right, involving deploying, managing, scaling, and scaling these containerized applications. As organizations begin to understand the benefits of these containerized applications, they start deploying a lot of them, but they run into management issues and they want the ability to orchestrate and automate certain processes. So that's Kubernetes, right? Hence the Helm logo. It's a layer that sits on top of containers to steer and automate the management of containers. Kubernetes is going to be very important in the future for delivering web applications. You may not have to deal with it right now, but at some point you will need to understand it so that you can play your part in managing it and securing it. So now that we have the basics down, have you ever wondered how a packet from a user ends up in a container, right? Or struggle to understand the difference between a pod, a node, a service, right? These are fundamental components of Kubernetes. What is an ingress, right? And how is it related to ClusterIPs or NodePorts or LoadBalancers, and how this all work together? We'll be answering those questions next. So to begin, we'll start with this very common starting point. We're all told the fundamental component of Kubernetes is a pod. So what is it exactly? To understand a pod, we need to look at a basic Docker container. In the diagram, we see a containerized application. All right, this containerized application has an Ethernet device. You can see that as vEth0, which then connects to a bridge interface that bridges the vEth0 with the actual physical interface, or maybe it's a VNIC, it doesn't matter, on the host. So this is how basic containerization works. From the host, right, the underlying host, we should be able to ping 172.17.0.2, right, and access its resource. And if we were able to then add a route to 172.17.0.0 on our router, an external device would then be able to access container as well. So what is a pod? It is literally just a container. So it's just container, but there are some special requirements. Notice how in this example, once we provision a second container, the new container has its own network interface or stack, and this is due to the container having its own namespace. So this is a Linux term that you guys can look up later on. But also, notice that each container in our example have the same port number, right? This is completely valid architecture. However, for Kubernetes, their specification indicates that pods must have a shared networking stack. So to further refine our definition of a pod, okay, a pod is just a container that has a shared networking stack. The reason why we can do this is that namespaces in Linux are flexible, and therefore we can have containers that share the networking stack. And the reason why Kubernetes wants to do this as a part of its specification is that it simplifies the networking component. Both containers can be reached by the same IP address. However, each container at this point, right, would need to have its own port. We can't have port conflicts. So what I'm about to talk about is a little deeper than I'd like, but I found it interesting is that a pod also has another unique characteristic. There exists a default container called pause, right? This container owns the interface, so owns vEth0, and is simply running the pause command. And the pause container provides the virtual network interface that all containers will then use to talk to other containers and outside the pod as well. This was designed so that the container can come and go, right? The containers rather can come and go. So whether they are restarted, upgraded, the interface stays in place. So to summarize, okay, guys, what is a pod? It's just a container with a shared networking stack, of course, which is now owned by a container itself called pause. So the next question is, what is a node? Right, at the very heart of Kubernetes design requires pods to be able to communicate with other pods, whether they are running on the same localhost or separate hosts. So a node is simply a compute resource which hosts the pods. The host could be bare metal or VM, it doesn't matter. Kubernetes consists of one or more. When we deploy containers in these nodes, it now looks like this. However, keep in mind, though we have talked about Kubernetes, there's actually no Kubernetes in any of my diagrams so far. We're simply laying out the foundational components according to Kubernetes specifications. So you can see how here on all nodes, local container to container communication and container to external, right, meaning outside communication is just fine. However, going from container to another node, so from the left to the right side, right, container one going to container one on the right side, that's going to be a problem, right? Because on the other node, you can see that the IP addresses are actually overlapping. So what does Kubernetes do to address this is to manage the IP addresses, right? Manage the IP address space for the bridges on each node, and then assigns corresponding IPs to the pods. And secondly, it adds routing rules to the gateway. So I understand some people want to call me out on this and correct me, but this is one of those gross simplifications that I mentioned earlier. So we'll talk about that later on. So imagine that a container on the left side is trying to talk to the container on the right side, right? Container would come out VETH0. I'm going to turn on my highlighter here, my laser pointer rather, right? Come out VETH0, go to CBR0, then go to ETH0, go to the gateway, right? Find that route, right, into CBR0. Therefore, it's going to send the packet then to ETH0, back into CBR0 on the right-hand side, and then back to the final destination container. So to summarize, a Kubernetes node is a host with an intelligently managed networking stack. So some of you might have noticed that in this particular diagram, Docker 0 is now CBR0. So the reason why I've updated this is to be more accurate to what you actually see in Kubernetes. Kubernetes does not actually use a standard Docker bridge, but a custom bridge. So this is just a fun fact. I figured I'd update the diagram. This architecture now allows us to have more than one pod per node. Take a look and notice that there's actually no natting, right? This is a very important concept for me personally to understand, that there's actually no natting involved, only plain old layer 3 routing. Pods can communicate each other, right, through this layer 3 routing and with the outside world. However, there's a fundamental problem, right, is that none of these IP addresses are static. They are ephemeral, right? You're going to hear that term a lot, meaning that they are ever changing. So to clarify, right, the whole point of Kubernetes is flexibility of pods and nodes, right, so that they can continue to come and go. Again, right, whether it's due to crashes, restarts, upgrades, you're doing some scaling, the IP address never stays the same for too long. So this brings us to Kubernetes service, right? What is a Kubernetes service? It's part of a solution to handle the fact that Kubernetes components are ephemeral, right? Ever changing. So services are designed to group similar containers together and provide common IP addresses to access these containers. Think of them as LB-VIPs in NetScaler terms. So a service also manages fully qualified domain names for those VIPs. So the reason we need the VIPs for these services is because it solves the fact that the back-end pods are ephemeral, right? Which means that in my diagram here, you look at server pod 1, right, and server pod 2, they may not have the same IP address as time goes by. So I'm a believe some of the people on this call, right, are NetScaler admins. Imagine having a NetScaler with an LB VIP where the back-end service members are dynamically changing IP addresses, right? It's a problem. And Kubernetes service not only manages the VIP, but also tracks the back-end IP changes. So let's say the client pod is trying to connect to a server pod, okay? And the VIP that's been assigned by Kubernetes is 10.3.241.152, right? Which Kubernetes has randomly generated. So let's follow the traffic and see how the client pod traffic makes it to the server pod. So we can see here, right? We'll start from the bottom left and go up again, right? The client pod says it wants to connect to 10.3.241.152 port 80, right? VETH1 rather, sees the packet and goes, nope, you need to go to my bridge device, right? And goes to the bridge device. Bridge device goes, nope, this needs to come out VETH0. And VETH0 then subsequently sends the packet out, right, to your router, your gateway. Now, if we were to do a network trace and watch that traffic coming out of ETH0, we'll notice that the packet has been rewritten with a destination of 10.0.2.2, right, with a port of 8080. And what happened, right? What's this wizardry? So kubeproxy is what happened. So kubeproxy saw the packet at ETH0 and found a match to the VIP, right, of the 10.3.241.152 port 80 and rewrote it to a destination of 10.2.2 port 8080. So the VIP isn't an actual IP address on the network. Okay, so that 10.3.241.152, right? It's not an actual IP address. What you like you would typically see on a reverse proxy. So they decided to make this a pretend network, if you will, in routing rules and firewall filters and etc. This decision was made to make sure that routing was not further complicated, right? However, you can see that you can't actually listen on a port or open a connection on an interface that doesn't actually exist. So the way kubeproxy gets around this is using a feature called NetFilter. So NetFilter is a rule-based packet processing engine which runs in kernel space. It matches a particular pattern set we're looking for and then applies an action. So you can see in the diagram, you can see kubeproxy and NetFilter does this additional translation. So NetFilter rewrites the connection to port 10,400, of which kubeproxy was actually doing the listening. And then once kubeproxy receives the packet, it then does a final rewrite, right, to that 10.2.2.80.80. So one problem with this is that kubeproxy actually runs in user space, right? So this makes it a very expensive transaction, right? And especially when compared to kernel space, right? Due to the need of this continually marshalling of packets. So what they actually did in Kubernetes 1.2 is they made a change. They made a change to where kubeproxy gained the ability to run in IP tables mode. So this meant that kubeproxy stopped being a proxy and instead delegated the work to NetFilter. You can see how the diagram is much simpler now, right? The benefit of this is that all the packet processing is now done in kernel space. So kubeproxy has been reduced to keeping NetFilter rules in sync and basically leaving the Kubernetes API rather, to interact with kubeproxy, which will then issue the commands to configure NetFilter. So now that we explained service IP and port, it's also easy to understand why service IP and port is only usable internally, right? So inside the Kubernetes cluster. Now, some fun things to note. A service IP cannot be pinged, okay? So if you were inside node 1 or node 2, you try to ping a service IP, it would fail because there's no actual interface to interact with. So service IP would have been a great name, right, for an IP of a Kubernetes service. However, right, because that is just way too easy to understand, right, as is tradition, Kubernetes wants to call it cluster IP. So the proper name for a service VIP, if you will, right, is actually officially cluster IP. So now the last piece, right, Kubernetes ingress. What is it? Well, to expose access to the service, right, or the cluster IP, we could simply add a route on our gateway to the Kubernetes cluster. And yes, we can do this. You can see, right, 10.3.2.40.0, right? And we're going to direct it to a node, in this particular case, node 2. You can see that red line that's been added there. However, we will have to remember that nodes themselves are also ephemeral. This means that nodes come and go, and those routes will break. And in addition, there's no load balancing to steer traffic intelligently between the two nodes. So the next logical step is that we add a load balancer like NetScaler ADC and steer the traffic to either of those nodes. So this has problems as well, as the ETH0 IPs aren't listening on any ports because the cluster IP, remember, the cluster IP, which is the service VIP, is what actually does the listening, if you will. The way around this is to configure something called a NodePort. So this actually opens a port on both of the nodes, ETH0, and starts listening. This is automatically generated and ranges from port 30,000 to 32767, and that port then forwards the traffic to the cluster IP in port. So this works great. Traffic flows properly. However, node IPs and node ports will change just like before, right? This is because nodes and its associated node IPs will also come and go. So to manage these dynamic changes, this is where something very cool comes in, okay? This is where a ingress controller, you'll hear that term at some point, an ingress controller comes in to play. An ingress controller is basically a pod or an application that you would install in Kubernetes that talks with Kubernetes APIs and automatically configures the load balancer, right? And as the Kubernetes environment continually changes. So this architecture is what Citrix calls our unified ingress architecture. So far we have talked about two services, right? That being the ClusterIP, which is used for service-to-service communication, NodePort, which then adds external connectivity to ClusterIP via opening a port on the node. And then the third type, which I've saved the best for last, is a service type called load balancer. So the most confusing service type, devoid of any useful information on Google. So what is service type load balancer and its associated external IP? You can see, when I go get services, right, in Kubernetes, it shows an external IP attribute. So what is this? So the answer is that the external IP address field is populated when an application is exposed as service type load balancer. And this is mainly available when you use a hosted public cloud Kubernetes platform, like AKS with Azure or GKE with Google. So what happens is that Kubernetes, through baked-in customizations made by these public cloud providers, will interact with their own built-in load balancer, like ALB or Azure Load Balancer, right, for AKS, for example, and will actually assign and set a public IP address on that ALB, right, for our Kubernetes service. So for bare metal Kubernetes, so meaning that is hosted in your own data center, this is more complex, right, because we don't have that customized integration. We would need to install something like a Citrix ingress controller, and then use in tandem the Citrix IPAM, right? So our own IP address management, and then use that in conjunction with Citrix ADC. So this service type is basically a shortcut to quickly expose an application with a public IP address assigned. So that is, right, with one command, we have the cluster IP configured, the NodePorts are opened, the public IP address is assigned on the ADC, for example, right? And the NetScaler VIP and members, right, are then subsequently configured. So that's it. Pods, nodes, service types. You should have a very basic but clear understanding of how traffic flows in Kubernetes. So I've spent a lot of time educating myself, trying to demystify Kubernetes networking. The only article of many that have really helped me to understand this was from Mark Betts, the source material of this presentation. I feel that by understanding the true foundational basics, even if it's not 100% accurate, I am now more confident in understanding how Citrix ADC fits into this new era of cloud native applications. And I hope that I've been able to do the same for you. I'd like to take a second to address what I said earlier about Kubernetes adding routes to the default gateway, right? I said that was a gross simplification. And that is true, right? That is not exactly how it works, right? Kubernetes does not actually make changes to your router, right? So your network team doesn't have to worry about that. This is all abstracted through something called a CNI, Container Network Interface. And it's handled on a per node level, and it's basically syncing routes, right, across all the nodes. So I was aware of this error, but thinking of it as a router just makes it so much easier to conceptually understand the traffic flow and the design decisions really made by the Kubernetes team. So as a side effect though, understanding the role of the router, right, now makes CNI, right, Container Network Interface, much easier to understand as well. So finally, I'd like to wrap up my session with a quick demo. This is my Kubernetes cluster. I built it on 2 Raspberry Pis. So I would love to show you, some of these concepts I've been talking about today. So I'm going to change my screen. Just give me a moment, guys.
So while you do that, Kevin, that's an excellent I'm going to call that a synopsis of containers. It really helped me understand a little bit more. It's really good. Lots of new concepts there, well explained, simply and clearly, and I appreciate that you went slowly. I think it helps the audience who no doubt have networking skills to really understand the subtle nuances of how things work in that cloud native world. And I like the way that you shared a little bit more than you wanted to, the pause container, for example. And I think it was a moment of clarity for me that really helped elucidate exactly how things work. And I'm like, wow. Plus, any presentation that uses the word wizardry, that wins my prize for interesting. So thank you for that. And then I'll just there were some good questions. Brendan asked for some more documentation on this, and I pointed to the Udemy course in the response to everyone. That was really good for me earlier on. But I've also look out for the stuff from, you say, Mark Betts that you listed. That was a good one. So excellent.
Absolutely, right. We will be sharing the recording. I will be sharing these links with the organizers, and we'll make sure to get this content out to you guys. Absolutely.
Right. And actually, one other question John was asking, are captions available for the hard hearing? I'm not sure that we do that here, but I've put out that we can share whatever scripting that we have in the slides with people if they want it later. We'll send the PDF version of the slides, which will help. But if you really you can't hear the audio, then let us know, and I'm sure that we can share any notes that you've made on this as well.
Absolutely. Yes. It'd be our pleasure to do so.
Awesome. I turn it back to you for your demo. Thank you.
Okay, perfect. Hey, so like you guys saw in the picture, right? It's a nice little Raspberry Pi cluster, and that's what's great about Kubernetes, right? Is that it runs on almost anything. So in my Kubernetes cluster, there's two Pis, and one is the primary, what they would call the master, and one's called a worker. So on the left-hand side here on the screen that I'm sharing now, so this one here is the master. You can see designated by the host name, right? I'm signed in as username Pi into master. And on the right side, I'm not actually signed into the worker. I'm actually signed on to just some random Raspberry Pi Zero I had lying around, right? Just to show you as a computer, right, if you will, that is outside the Kubernetes infrastructure. So the first thing I want to do is I want to show you some of the services that I actually have running in here. So just give me one moment, guys. So I'm going to do sudo kubectl get services -oy, right? And just like anything in Linux is all command line based. So what this command does is it pulls up the services, right, that I have configured. And you can see that by default, we have the Kubernetes service itself, right? So this is what the Kubernetes API's IP address, if you will. We don't necessarily have to interact with that. But what I want you to pay attention to is that second service called Figlet service. So what Figlet is a web application that simply echoes. It simply echoes whatever I post, right, through a command line. So I'll show you guys what that does. So basically, what I'm doing, right, is I echoed, right, the string I love Netscaler, and then I'm piping it through curl, right, into this particular service IP address. Remember, this service IP address is not an actual interface, right? It doesn't actually exist. It's simply being handled by NetFilter to do that rewrite. And you can see that my web application responded, right, with this lovely ASCII version of my string that I piped in, right? And that's all this application does. So if I were to then subsequently ping, right, 10.43.194.106, you can see that it fails, right? Because again, it's not an actual interface, right? Look at it, think of it as a VIP for Kubernetes, right? That is being managed by NetFilter, and it's only there, right, to be then subsequently translated on later on. So I'm going to now show you guys. Let's see. This is my home router. Okay, you can see that I'm not running anything fancy. I use the default subnet that everybody and their mom uses over here, right? The .1 network on 192.168. But what I did was I added a route, right, a /32 route to that service IP address, right? And I set the next hop to be the master, right, which is 1.165. So I'm going to flip back now. So now, right, from my random PC, I'm going to do the same. I'm going to ping that service again. Okay. So I'm going to ping, what was it? 1043.194.106. All right. Hit enter. Same thing, right? No response. All right. So though it is no response, if I were to execute that same echo command, right, that was piping through curl, I'm going to paste that command into here now. You can see that that web application was accessible, right? So you can see that despite that service IP not being an actual interface, right, as long as we set a route to it, right, we can actually access it. So now I'm going to show you guys what some of these pods look like. Just give me a second here, guys. I'm just copying and pasting the command as well out of my notes here. Oops, sorry, guys. I'm going to change that to a dash. And you can see that these are my pods, right? So in this particular case, I'm actually running 3, they call it replicas, right? 3 replicas of the Figlet. And you can see that 2 are running on the master node and 1 is working on the worker node. And you can see that each individual pod has its own IP address as well. So if I were to then ping, right? Remember, I'm on the master node, right? I'm going to ping a master, a pod rather, that is on the master node. You can see that the ping works just fine. Okay. And I'm going to now ping the pod that's in the other node. Okay. And I'm going to sudo route. I'm going to show you guys my routing table. And you can see that, right, the other one is a subnet of .2, right? We're .0 on the master, but .2 on the worker. And you can see it right here. I have a route, right, to the .2 subnet, okay? And it's actually managed by an interface called Flannel. So Flannel is my CNI, right? That route synchronization mechanism I was telling you guys about. So because I have this route in here that's being managed by the CNI, which is Flannel, if I were to now go ping, right, 10.42.2.17, I should get a response, right? So now I'm actually pinging, right, from node to node. And that's all I have for you guys. I wanted to really thank you guys for attending, and I'll pass it on to my next presenter.
Well, just before you do that, hold on just one second. I love NetScaler. A good friend of mine, Al Taylor, came up with badges for that. They were very, very popular within Citrix and outside of Citrix. But Kevin, that is brilliant. I just want to we're going to run a poll just to check with our audience. How far along? So let's launch this, and I'll talk over the top a little bit. Is your organization using containerized applications? So is this something that's new to you, or is it something that you as networking admins are, as I said before, having to get involved with? Because developers are great at going and building all this stuff, and they get all this information, but the delivery of this stuff is actually, I think it's really crucial. And I know that we have done a lot of work at Citrix around the ingress. You mentioned that earlier, Kevin, and we've done some great thought leadership articles around type load balancer and using the Citrix ingress controller. And there were some good webinars that Pankaj Gupta, my boss, did with, I forget the name of the people he did it with now, New Stack and the CNCF Foundation. I think that was it. And so if you want to learn more, check that out. That would be really great. But is your organization using containerized applications? Yes, all new apps are done that way. Yes, some new apps and some are done the traditional way, or no, we're still using traditional apps, or maybe you're not sure. As we said, a lot of people just aren't sure, and we'll share those results in a moment. But Kevin, I just wanted to say, excellent. I love the way you tied virtual machines, which everyone understands, and you gave the reasons why people might want to use containers over those. And I just go through those again. Upgrade more easily. What were the main reasons for that?
So much easier upgrades, right? And not only that, because of the fact that Kubernetes automates, right, the dynamic changes, right? It makes development a lot easier. It makes rolling out new code a lot easier, right? It makes testing new code a lot easier. And it also makes your application way more resilient as well, right? And you're not bound to a particular hypervisor or an operating system, right? You can really spread this out, to public cloud, on-prem, right? And have a very robust and resilient application.
And much lower resource use, right?
Oh,
Which I think
absolutely.
That was always the thing that stuck in my mind, but you're right, it's so much more flexible. Okay, what I'm going to do now is I am going to close this poll. And interesting result, let me share the results. So yes, it's a mix, and I think people are on a journey to cloud native applications, and some are not sure. So if you're not sure if your organization's using them, ask around whoever's developing your applications, or even reach out to Citrix and we'll come and ask with you. Or if you are using it and you're along that road, reach out to us, reach out to your local Citrix reps, and we will try to help your organization make those applications, those new applications, a better experience for everyone involved. So hang on just one second. I've got one more question to ask you, but as we do that, I'm going to set up Komal. I'm just going to make you presenter, Komal. If you bear with me just one moment. Let me just do that. So now you can make yourself presenter, and we'll see your screen. But Kevin, we got a great comment from Brian here. He said he loved the demo, and interesting and much interesting. And no need to do a sales pitch for Kubernetes. All right, thanks, Brian. I like the smiley thing. That's great. Is this applicable for Red Hat OpenShift containers as well? Is the question from Mohammed?
Absolutely. Yeah. Right. That is just their particular distribution of it.
Right.
But absolutely, it's 100% applicable. And not only that, Citrix is a very, very good partner with Red Hat, and we have a lot of integration with OpenShift.
Good stuff. I'm going out on a limb here, and you can say no. Don't feel pressurized at all with the fact that we've got thousands of people in the audience. But I loved the Raspberry Pi demo, as did Brian. And I was wondering if you might share configs for that, or like write up a little bit how to get that going, because I know a lot of people, you can read the theory, but actually having the demo to play with would be really useful.
It'd be my pleasure. Not a problem at all.
Okay. So if you want more information on that, reach out to networkingmasterclass@citrix.com, and we will make sure that we can get the config files and how to do this to you, or just ping us put your email address in the question pane, and we'll try to get this over to you in some way as quickly as we can. All right, so Komal, are you there? Oh.
Yes, Jason, I'm here.
Okay, are you sharing your screen? I'm not seeing it. I'm still seeing mine, so let me, I have to do that maybe. If I hide results, then we can come to your screen. There we go. Okay, so thanks very much, Kevin. So Komal, the community platform for Citrix application delivery and security products. I think you touched upon it last month, or somebody did, and I know we've seen some blogs on it, and we've got some people contributing to it, but tell us a little bit more about it.
Yeah, sure, Jason. And hello to everyone on the webinar. I'm Komal Bhardwaj, and I'm a part of the Citrix ADC and the whole application delivery and security product management team. And I've been presenting at the masterclasses earlier, awesome experience. And today I'm going to touch upon a very new, fresh initiative that is very close to something what Kevin was also talking about, but in a broader sense, we are coming up with a community platform so that the modern application developers, the modern DevOps, modern platform operations team, they can come and learn about how Citrix application delivery and security products help them in their application modernization journey. So we introduced the application delivery and security community platform in October as a part of Citrix Converge, which is Citrix's developer event. And during that time, we launched the community platform. We did invite a lot of the Converge attendees who checked out the platform, and a lot of them signed up on the platform as well. So I'm going to talk about the idea behind this platform, what we have in store, and then since this is a community, we need lot of end users, we need a lot of practitioners, and we need people who are dealing with Citrix ADC or Citrix ADM for all the cloud and cloud native and the security use cases. So what is the application delivery and security community platform? It's a part of the developer portal. It's a part of the developer ecosystem set of products, and it figures here on developer.cloud.com/community/application delivery and security. So I'll post this link so that Jason can share it with you on the chat. So this is the first version of the community platform. Right now, this hosts a set of very interesting articles on how you can get started or how you can execute some advanced use cases. There are several focus areas, but we have combined it into these 5 broad categories, which we feel are really relevant to how applications are being delivered in the modern enterprises. And these areas are the general application delivery on any public cloud or any private cloud, the security capabilities that Citrix ADC and ADM offers. Microservices category is for the cloud native or the Kubernetes ecosystem, which was discussed in detail by Kevin before me. And automation is something which has several manifestations in terms of automation using Terraform or Ansible, or using the public cloud templates such as AWS CloudFormation template or Google deployment template, and so on. So these are the 5 broad areas under which you'll find a lot of engaging content in this community platform. And initially, the articles and the content is being provided by Citrix team, but slowly we are seeing a lot of interest from our partners, and we will also invite our end users who work with Citrix ADC day in, day out, so that you can also share your best practices. You can also share how you achieved a particular use case for these categories. So if you are interested, just check out, just go to any of these register now links, and you'll be presented with a short form so that you can be a part of this community and submit your email ID. And in near future, in a few weeks time, we will be adding a lot of interesting features to this community, so that you can join from your social identities like GitHub, Twitter, and so on. You will be able to author articles very easily, very seamlessly on the browser itself in Markdown format. And there'll be a lot of gamification elements like badges, and if you are a beginner level community member, or if you are an advanced community member, and there will be a lot of exciting features as a part of this community. We'll also be adding some interesting type of content, such as live talks or hackathons, and we are open for your ideas, so that you can tell us what kind of new content or what kind of format you would want to see. And as this is a community platform, so initially we'll seed the community with a lot of interesting content, but going forward, we want that a lot of comments and a lot of articles should be submitted by the end users and the practitioners. So that's the aim. So this community is, so we want to nurture a community of cloud operations, DevOps, DevSecOps, and NetOps, and the IT Ops. Mainly the audiences, the customers who use Citrix ADC and ADM for their modern application portfolio. We want this community to be a good place for nurturing how you learn, share, showcase your knowledge with other members. And there'll be several examples for you to get started, solve some specific use cases, or if you want to learn some concepts in depth. And I told you about the focus areas of automation, infrastructure as code, microservices, and so on. One very interesting concept that we're going to introduce as part of this community platform is our Handson Lab, or is our playground or sandbox environment that you can use on the browser itself, so that you can experience how Citrix ADC and EDM work in the modern cloud and the Kubernetes ecosystem. So I have one example in which I'll show you live how you can learn about Citrix ADC CPX on the browser itself. So, so this is one lab in which we have created a very simple example on how you can bring a simple application, and this is by coincidence, this is a cloud native application only. It could be a VM based application also, but you can see on the right hand side there are simple steps on how you can create a simple application, and then you can see whether it has been deployed or not. So this steps takes a couple of minutes, so I've done it earlier for just to save some time. And on the browser itself, you can move forward, and then you can see how to deploy Citrix ADC CPX. And this is all on the browser. All this infrastructure is getting spinned up in public cloud behind the scene, and you will be able to learn the basics on the browser itself. So the first step is done. It was earlier, so we were till now only deploying a simple application. And now let's deploy Citrix ADC CPX in this Kubernetes cluster. So you can see on the right hand side, there are simple steps. Right now, we are just adding the Helm repo. So I'm just copying the command here. I'm waiting for the terminal to appear. And so this will add the Helm repo. And this simple command of Helm will install the Citrix ADC CPX with the Ingress controller. So you can see whether this has got installed or not, and you can see that the first 6 spots, these are related to the application, and then this is the Citrix ADC CPX. So this example shows how you can use a very simple application and expose it to the internet using Citrix ADC CPX. So, so right now this container is getting created. It might take 20 or 30 more seconds. So we'll wait for that. Yeah. So you can see that it is running, and now we move to the next step, where we will deploy the ingress on this setup, so that this application will be exposed to the internet. So now we will expose this application with HTTP protocol using Citrix ADC CPX and the Ingress resource. So now this application, so I'm now using the Ingress here. So I'm telling Kubernetes to create an Ingress whose name is guestbook HTTP Ingress. And the rule is that the front-end application should be exposed on port 80. And now you can see that on the HTTP guestbook application tab, this application is up and running. This is a very simple application in which you write any message and it will be saved here. So this is an HTTP application, and we can, right now the HTTPS application is not working because we had only exposed the Ingress as a HTTP Ingress. Now in the next step, we will expose it as a HTTPS. So you'll see that on the browser itself, commands will come so that you can read that, and you can play around with the HTTPS configuration as well. So we are firstly installing or creating the secrets to be used for HTTPS, and now we are creating an ingress with the HTTPS, and you can see now that the HTTPS ingress is up. HTTP is also up. Hello. Right. So now you can see that the application is running on HTTPS. So this is a very simple demo of the possibilities that are available on this community platform. We will be coming up with several such labs so that if you are at a beginning level or at an intermediate level, you can learn about Citrix ADC features and use cases on the browser itself. So you don't have to worry about provisioning your own VMs or your bare metal to try out Citrix ADC, CPX or VPX, download the image and go through all these steps just to experience that first handshake with the product. So all of that is being abstracted away, and we're creating several such getting started labs. So as a part of this community platform, so I invite you to check out this platform, register on it, read some articles that we have launched till now. And if you're interested to contribute, then you can just drop us an email as well. This email ID is available here. You can drop us an email on this inbox, so that if you are willing to contribute, then you can contribute. In a few months' time, I'll be back again on this masterclass, and I'll talk about the new version of this community platform, which is going to be even more exciting for you. So with that, I am about to close my presentation. I would request Jason to please show the poll question.
Yeah, absolutely. So thank you, Komal. That's a fantastic presentation. This is something that's been, I think, long overdue, and it's easy to navigate. It's called the use cases for Citrix ADC users and admins. I think it'll be very useful for those on this webinar. There's definitely something for everyone. I'm going to just launch a poll. So if you'd like to contribute to this, do you want to join the platform and use it as a resource, or you want to contribute, or maybe you want to wait a little bit later? Just let us know, and we will take that into consideration. But I think one of the great things that this brings to me, Komal, is the fact that we try to guess what people want, and we speak to a lot of customers, and they tell us the things they want, and that's great. We can work with that. Masterclass is a good avenue for feedback, but this broadens that avenue for those that really want to tell us, look, we wish that we're trying to do this and we want to know how. And so it's something that we can address, or other members of the community can actually help you address. So please sign up, even if it's only in lurking mode, that's okay. But we would really love you to sign up and contribute your thoughts, comments, and suggestions as well, because we learn from you as much as you learn from us, I think, because we don't always know what it is that you want. So if you can do that, then we can help give you more of the things that you really need. So whilst that's running, I will just close that poll and share the results with you. So it looks like everyone, well, a good half want to join, and 20% would like to contribute as well. So that's great news, Komal, and we will get this information to you so that you can communicate with them and get them on board as quickly as possible, because I look forward to hearing about what they want to do. And I really love that everything in the browser learning platform. That's got a lot of scope for moving things forward in the Netscaler or the ADC community. All right, so let me hide these results and I will take back the presentation. So thank you, Komal. Let me do this and that, and I will show my screen. So that seems to be working, which is good. And so I have to do this manually. There we go. So got a couple of things about what else is happening. So I think that we had a short webinar on this last month, and that was the new, coming in January, the new application delivery and security service that we're launching. And this will be a new way of delivering application delivery, deploying and maintaining application delivery infrastructure as we go forward. I'd like to say that this will democratize it so that you as networking admins can actually give this over. You've got application developers and you want to say, okay, look, take the ADC, deploy it in front of your application and leave me alone, and I can work on something that's a little more strategic. We can take away a lot of that operational overhead. So this is a new service, ADC as a service, that we're introducing, and we think it's a bit of a paradigm shift, because it's not just go and deploy this and then manage it and maintain it and update it and stuff like that. We're starting to make it a little bit more intent driven. So what does this mean? So this means that when a business says we want to deliver our applications in a certain way, they define what that intent is, and then this new service turns those intentions into policies and then into configurations for the ADCs that are then automatically deployed in front of the applications themselves. At the moment, it's working only, I think in launch it'll work on AWS and Azure, so in a cloud environment where we can use the cloud environment to orchestrate the ADCs directly into your own networking environment, your VPCs. But in the future, we're looking to maybe we can do some of this on-prem for those that have got some sort of cloudification in their environments. And I just want to talk about a few things. So we built this modeled on 4 basic human principles. 1, intent driven. 2, that it's always learning. 3, it's always adapting. And 4, always protecting. So what do we mean by that? So humans have been evolving for millennia, I suppose, or centuries at least, before we and we do this ourselves. We turn our intent to take a vacation into a series of actions, and it's those actions, as I'm finding out right now, they're just painful to get through all the little things. Did I book the hotel? Did I get the restaurant sorted? Did I do all these little things? And so it's like a travel agent. I would prefer to just give this, say, I want to go to Hawaii, book this all for me. And that's kind of what the app delivery and security service is doing. So you say, I want this application to be fronted and load balanced and delivered with a certain amount of a maximum latency, and then the application sets things up to do that for you. And it's always learning about the environment, just as humans are always learning about their environment. This is always learning about the everything from the end to end, from the user to the data center to the state of the internet in between. And so it can know exactly what's going on and make adjustments. That's the always adapting part. It can make adjustments on the fly to the environment and its configurations to make sure that you stay within the the declarative intent is always continuously enforced. And we call it, something breaks, we will self-heal. So if a server goes down, we can remove that server from the pool and then trigger a new server to be set up by talking to the back-end cloud service provider. Say, set this server up with this configuration and application on it, and we'll add it to our load balancing pool to make sure that you have enough resources. And of course, we'll scale up and down depending on the fluctuations in the traffic. And of course, being built on Citrix ADC, security is inbuilt into the ADC for the applications and APIs themselves. So this is the new thing, and I think there's a bit more detail on it in last month, and I'm sure we will cover it again next year with some more examples and some use cases and so on. So just be aware that that's coming. Watch out for more announcements from Citrix, and we'll be releasing this, I believe, in January or February next year. We've been talking to a lot of analysts about it, and they're saying this is really cool. You're taking a lot of those self-learning, self-healing, intent-driven networking concepts and bringing it to application delivery, which is completely a first for anyone. So stay tuned for that. Okay, so what's happening? Well, we've covered a lot of modern app delivery requirements this month, and this first one here is meeting modern app delivery infrastructure requirements featuring IDC. This is a great webinar. Pankaj Gupta, who's the head of our product marketing for application and delivery and security, he lines up with Brad Casemore from IDC, so it's quite a big analyst there, and he's going to talk about the requirements for delivering modern applications in a hybrid and multi-cloud environments, what businesses need to consider when deploying solutions to ensure that user experience and application security. It will be a cracking webinar, I promise you that, so sign up and attend, and they'll be talking a little bit more detail about why we're introducing application delivery and security service that we just talked about a moment ago, and sort of give you a few more use cases. And we'll cover it in more depth as we go forward, but that would be a really good place to start later this month. Okay, next up, field kickoff. This one is for Citrix partners only. It's that time of year. Book the dates now. January 18th to 22nd, Citrix is hosting a virtual event for partners to come along and learn about our vision, direction, and all the product updates. So not just for app delivery and security, but across the board. It promises to be an exciting, fun, and rewarding 3 days of presentations, workshops, and learning. So click on the link and sign up. And lastly, don't forget that the masterclass will return in February next year. So look out for an invitation email in January and join us for more fun app delivery and security learnings as we go forward into the new year. So before we wrap up, I will just take a quick check. I thought I saw that there was a question. No, it's just a repeat, so that's fine. So with that, we're done. I really appreciate you all staying on and sticking with us. So it only remains for me to thank our presenters, Kevin and Komal, and to wish you all a happy holiday season, and we'll see you in the new year. Thank you very much.